Hello my lovely students, welcome back once again to chapter named Solid State. I am your host Manjot Singh, and we had already begun with this chapter in which we had just introduced you to the state called solid state, and we had explained you that why this chapter is of utmost importance in our syllabus of class 11th and 12th, right? In the previous session, we have just finished with the first flow of the chapter, that is nothing but characteristics of the solids. So there were some points enlisted, and I told you that technical language of those points is going to be of utmost importance. In today's class, we are going to talk about the types of solids, right? The types of solids is very important to understand. Why? Because the types of solids is going to give us an insight that all the elements, 118 elements we have talked about, out of the 118 elements, almost 100 elements were in their solid state. So we need to understand basically that how are these solids classified. So these solids are basically classified into two categories. The first category is crystalline solids, and the second category is amorphous solids. See, I'll try to bring about as many pictures for you as possible for this chapter, because this chapter involves a lot of imagination. I have told you that in previous class also, right? So as the picture comes, try to imagine what I'm trying to explain over here. We can see that there is a much regular arrangement of the particles, in case of crystalline solids, whereas in case of amorphous solids I can see that there is a lot of haphazard arrangement of the particles. That's what this picture is depicting. Yes, and that is exactly what a crystalline and an amorphous solid is. A crystalline solid is nothing but when the building constituent particles arrange themselves in a regular manner throughout the entire three-dimensional network. Very important. A regular arrangement of constituent particles throughout the entire three-dimensional network is known as crystalline solid. Whereas amorphous comes from a word that is amorphy, meaning shapeless. So from there the definition comes that it's a solid where no regular but a haphazard arrangement of building constituent particles. And when we talk about the examples around us, the examples of these two solids can be seen on your screen. Sodium chloride, it's a crystalline solid. When you talk about microscopic level, yes, we are not talking about when the salt is in your hand. No. At the hand level, at the naked eye level, you cannot differentiate as crystalline and amorphous. No, you cannot do that. But yes, we have studied the structure of diamond, where you have seen that carbon is tetrahedrally arranged by 4 other carbons around it. And this pattern keeps on repeating throughout the structure of diamond. That is a regular arrangement. Quartz, gold, iron, copper, all your naturally occurring metals around you, they are generally in crystalline form. Whereas you talk about amorphous solids are like glass, rubber, plastics, etc. So this basically is the introduction to crystalline and amorphous. But yet so many questions are unanswered in our mind over here, right? So to do so, let's see what is actually the difference between crystalline and amorphous solids. And let's do it in the form of a difference table only, so that it becomes easy to understand. First of all, Let's see the first point. The crystalline solid, it says the internal arrangement of the particle is regular, so they possess definite and regular geometry. Very, very important word is being used over here, a long range order. There is a long range order of the particles having regular arrangement. We saw that just in the previous slide. See this, a regular arrangement of the particles is going on, and it will go on indefinitely. Similarly, you see the amorphous solids. Amorphous solid says the internal arrangement of the particle is irregular. Once again, going back and seeing, see this, there is an irregular arrangement, no arrangement, haphazard arrangement. कोई भी shape नहीं बन रहा है यहाँ पर, right? So they have a very short range order. They have a very short range order and they do not have any definite geometry, whereas the crystalline solids, they have definite geometry. Then, since the arrangement of the particles is extremely regular, so you pull out any portion of a crystalline solid, it is going to melt at the same temperature. So basically they have sharp melting points. That is, they melt at constant temperature when held prolonged at their melting points. For example, iron, it has a sharp melting point, 1600 degrees Celsius. You talk about copper, it has a sharp melting point. You talk about zinc, it has a sharp melting point. You talk about NaCl, sodium chloride, it has a sharp melting point. It will have a single melting point. Whereas in case of amorphous, we just saw that in case of amorphous, the arrangement is so haphazard that if I pick a region over here for amorphous, let's say this region, then I pick another region, let's say this region, you can see the particles are different. The arrangement is different. Hence, this area of the solid is going to melt at X degrees Celsius, whereas this area is going to melt at Y degrees Celsius. And hence, the complete solid is not going to have a sharp melting point. They are going to melt over a range of temperature. Correct? I suppose you get this point. Then crystalline solids, there is regularity in external form when crystals are formed. What is the meaning of this? कि जब एक crystalline solid बनता है तो आपको एक smooth surface मिलेगा, something like this. जैसे एक cube होता है ना, a smooth surface, and you can feel that by pulling one of the particles of NaCl. Salt को अपने हाथ में लो और उसमें से एक तिनका उठा के just try to feel that you're going to feel a very smooth surface. Is that clear? Whereas it's exactly opposite in amorphous solids. आप बोलोगे सर plastics भी तो smooth होते हैं. बच्चे, we are talking about at microscopic level. We are not talking about at macroscopic level. No, we are talking about at extremely microscopic level. So plastics जब बनते हैं तब उनका जो सरफेस है वो स्मूथ नहीं होता है, वो बनाया जाता है एक्सटर्नली. इज दैट क्लियर? देन crystalline solids will give a regular cut when cut with a sharp edged knife. Regular cut मतलब एक clean cleavage मिलेगा आपको. जैसे आप एक आयरन रॉड को काटो, you might have seen that. एक आयरन रॉड को जब कट करते हैं तो जो कट वाला जो सरफेस होता है, that's extremely very sharp surface. Whereas in case of amorphous solids, it's going to be an irregular cut. प्लास्टिक को तोड़ने की कोशिश करो, it's not going to have any regular cut. It's going to be a very haphazard cut. कहीं से भी किधर से भी टूट जाएगा वो. Is that clear? Whereas iron, copper, zinc, these elements, they are not going to get cut like this. They are going to give you a clean cleavage. The next point, they have characteristic heat of fusion. Similarly, the point we talked about, they have sharp melting point. Heat of fusion का मतलब वही होता है, conversion of solid to liquid. Similarly, amorphous solids, they will not have characteristic heat of fusion. Is that perfectly okay? Crystalline solids are rigid. Very important. Sir, क्या बात कर रहे हो? Solids तो rigid ही होते हैं. And these are two parts of solid. तो अमॉर्फस सॉलिड्स भी रिजिड होने ही चाहिए, बट द पॉइंट ओवर हियर, since the arrangement of the particles is not regular in case of amorphous, they are rigid, but they are not that rigid that they can actually give you the properties of the solid rigidity, and that's the reason they are called as pseudo solids, and crystalline solids are known as true solids. Pseudo का मतलब तो हम सब जानते हैं false solid. So this is the reason that amorphous solids, they are named as pseudo solids, or sometimes they are also called as super cooled liquids. Yes. आप बोलोगे सर लिक्विड्स में तो टेंडेंसी होता है फ्लो होने का, तो यस बच्चे, अमॉर्फस सॉलिड्स, कुछ अमॉर्फस सॉलिड्स ऐसे हैं जिनके अंदर पार्टिकल्स जो हैं दे फ्लो अंडर द फोर्स ऑफ ग्रेविटी. यस, इफ यू टॉक अबाउट अ ओल्ड बिल्डिंग, कोई भी ओल्ड बिल्डिंग अहमदाबाद में, एक सिटी एरिया में, जस्ट गो इनटू एनी ऑफ द सिटी एरियाज ऑफ अ ओल्ड सिटी एंड जस्ट ट्राई टू वॉच द विंडोज ऑफ दैट building. What you will see is that those windows, they are thin at the top and they are thick at the bottom. I'm talking about the glass in that windows. Why is that so? Since glass is an amorphous solid, it's an amorphous solid, right? So under the force of gravity, the particles over the ears, see, I'm using the word over the years. It is not a matter of 1 day, 2 day, 3 day. No, over the years, 30 years, 40 years down the line in a building, you will observe that the glass panes, they become thicker at the bottom and thinner at the top. This is a very, very important question also. ये पूछा जाता है that why the glass panes in the old buildings are thinner at the top and thicker at the bottom. So you have to tell that since glass is a supercooled liquid, it is a supercooled liquid, hence it is an amorphous solid. An amorphous solid has tendency, the particles of amorphous solids, they have tendency to flow under the force of gravity, and that's the reason that the down part of these panes, they become thick, and thick के साथ साथ इनके ऊपर एक कलर आ जाता है, मिल्की वाइट कलर, एक sluggish milky white color दिखेगा आपको. So that's another way of asking this question, that why the window panes in the old buildings show milky white color at the bottom. So these are the variety in which the language can be twisted and asked. Correct? So these were the 6 points of the difference between crystalline and amorphous. And then the last point of difference between these two solids, that's the most important point, and that is there on the screen, that crystalline solids are anisotropic in nature and amorphous solids are isotropic in nature. See, understand, this is very important. Both of these properties are against their definitions, but we need to understand this. I'm going to explain it in a very easy way with the help of diagram so that you do not confuse between this. But let's understand what is the meaning of tropic first of all. Tropic over here means the properties. अगर उसके वर्ड आगे मैं वर्ड लगा दूं आइसो, तो आइसो का मतलब होता है सेम प्रॉपर्टीज व्हेन वी मूव इन डिफरेंट डायरेक्शंस इन अ सॉलिड. एंड उसके अगर आगे मैं एन लगा दूं, एन आइसोट्रोपिक, तो एन आइसो का मतलब होता है डिफरेंट प्रॉपर्टीज व्हेन यू मूव इन डिफरेंट डायरेक्शंस. तो देखो, आपके दिमाग में ये चीज चल रही होगी कि सर क्रिस्टलाइन सॉलिड्स के अंदर तो हमारे पास डेफिनेट अरेंजमेंट होता है, तो हाउ कम दे आर एनाइसोट्रोपिक इन नेचर? That's the point where the examiner will take the advantage. He knows you are confused between this point and he will ask you, explain the anisotropic nature of crystalline solids. So what are you going to do over here? You're going to do very simple thing. You're going to just see this diagram and understand. The language is written. You have to write down the language. You do not have to draw this diagram, but you have to just picturize this. I told you, imagine karna hai is chapter mein. So if I take crystals of crystalline solid, you understand that this is a regular arrangement. And similarly, if you talk about amorphous solid, this was a crystalline solid, right? If you take amorphous solid, you see there is no regular arrangement. So when we go in one direction in a crystalline solid, that is this over here, see that, the B direction, you see there is a green ball, there is a pink ball, green ball, pink ball, green ball. So the arrangement is green, pink, green, pink, green, pink, like, correct? That's your B direction. Similarly, when you go in A direction, you see all the balls are pink, 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 pink. So the particles are changing in this direction, right? Similarly, if I take another direction over here, let's say the direction is this, C direction. So C direction, you will see all green, 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 green balls. So in crystalline solids, due to their regular arrangement, what happens is when you move into different directions, the concentration of the particles is changing. And since the concentration of the particles is changing, the average value, see, understand this, average value of certain properties, certain physical properties. Which are those physical properties? Refractive index, conductivity, thermal expansion, electrical resistance. All these are physical properties which have different average values in different molecular directions. Whereas when we go into amorphous solids, the concentration of the particles is so haphazard, it is so haphazard that you take any direction, in this solid, what you will find is that average values are going to be very, very close to each other for these physical properties. That is refractive index, conductivity, electrical resistance, thermal expansion. And this is how you have to explain it. It is the word average value which actually is missed in your NCERT also. So please understand this, that why crystalline solids are anisotropic in nature, because when we move in different directions, the concentration of the particles is different. I explained you. In one direction we are having green, pink, green, pink. In one direction pink, pink, pink. In one direction green, green, green. Whereas in case of amorphous, it's already so haphazard that the average values, they fall very close when we move in different directions. And that is why they are known as isotropic solids, and these are known as anisotropic solids. Very, very, very important question. Look at my emphasis. Please make sure that you understand this point. If you have not, just reverse the video back and understand it once again. But this has to be completed. Now, understand this. Around us, we saw that out of 118 elements, there are almost 100 elements which are actually solids in nature. And those solids are classified into two portions, that is crystalline solids and amorphous solids. Crystalline solids are those in which at microscopic level the arrangement of the particles, that is either atoms, either molecules or ions, whatever that solid is made up of, the arrangement of those particles is regular arrangement, long range arrangement. And what we see is that out of those 100 elements, almost all of these elements, they fall into crystalline category. और कौन नहीं होना चाहेगा भाई? आपको दिख रहा है अमॉर्फस में अरेंजमेंट हैफाजार्ड है, तो वहां पर अनस्टेबिलिटी रहेगा. तो जिंदगी में हर कोई स्टेबल बनना चाहता है, तो हर कोई क्रिस्टलाइन सॉलिड ही बनना चाहेगा. बट देयर आर certain elements which do not let certain solids to fall into crystalline nature, and hence they become amorphous. So it becomes very, very important point to understand over here that in this chapter we are going to concentrate our studies on the crystalline solids, and that's why we need to first understand that what is the classification of crystalline solids. But for that you will have to wait for few more minutes, few more hours, because that's going to be taken up in the next video. So we'll meet up in the next video once again with very important part. Classification is not over yet. पहला classification हमने किया solids का, crystalline and amorphous, that was done in this session. Now we saw that out of 100 elements, almost all of the elements they fall into crystalline category. Elements की बात कर रहा हूं मैं, compounds की नहीं. ध्यान से मेरे words को सुनेगा. I am talking about elements. They are crystalline in nature. So hence it becomes important to understand the classification of crystalline solids, which will be taken up in the next session. Till then, please take care of yourself. I'll meet you soon. Bye-bye.